Hey guys, how's everyone doing today? So, I'm here to talk about what we did. I'm from Argentina. We're a consultant company called Edrans. We basically do infrastructure consulting, some software development. We specialize in monitoring automation, and we are the official Puppet Labs partner. So, what happened here is that we were contracted by an Argentinian healthcare provider to actually re-implement and help them solve a lot of the issues they were having with their infrastructure, right? So we're basically a team of a few people. We specialize in automation to help us handle a lot of the difficult tasks of managing lots of servers. Yeah. So that's what our company does. Who am I? I'm Pablo. I'm the system engineer manager at the company. I'm the Puppet instructor for most of Spanish-speaking Latin America and Central America. I'm obsessed with Linux, graphs and metrics, automation, and graphs. That's in there twice because I really, really, really love graphs. So that's who I am. I'm usually right there on the IRC channels, on the mailing list. We actually manage a Spanish-speaking mail list and a Spanish-speaking IRC. So yeah, we're around everywhere. And this is my buddy, Pablo the Puppet. I actually brought him along so you guys can meet him. He's not going to speak today because he's kind of camera shy, but he's here. So here you go. It's a fun little thing we had done. So there. So let's get down to business. So we were actually contracted by this government agency, right? So what is it? It's a healthcare provider for pensioners and retirees, right? So it's free. It's available to anyone over 65, basically, or anyone on a government pension. It was created in 1971. And it actually covers the whole country. We are a 40 million people country right now, more or less. So it's an important number. And this agency actually manages not only the healthcare part, but also anything that's tracking the import of any medication, any payment of pensions, and a bunch of other stuff that we're going to talk about soon. So here's a couple of stats. So like I said, we're 40 million people. About 4.5 of those are actually members of this, are subscribed to this healthcare. The country actually has about 120 healthcare centers dedicated especially to this agency. That is without taking into account all the general purpose healthcare centers that actually provide some of the services through this company, right? So it has about 700 offices, like between administrative offices and support offices around the country. And they currently have about 80, a couple of bit more, it's like 83, 85 different stacks to manage all the services. So you can see it's quite a bit. The number of users, it's on par with a pretty big company, right? And all this right now is managed by a team of 20 people. This is pretty cool. This was already like that when we got there. So they were actually doing coverage like 6 a.m. to 10 p.m. on the weekdays. So they were actually maybe a 10-people crew most of the time. And that was already pretty cool. So what they wanted us to do, they wanted us to improve the quality of the services, both of the internal and external services. They manage a lot of, they manage basically everything that has to do with patient registration, patient subscription to medication, patient when you have to go to the ICU and all that stuff. They manage a lot of stuff, right? So what they needed us to do was to actually improve the service level. They had a lot of problems with outages and recovering from certain disasters that might have happened. So that was one of the biggest points, like making sure that the quality of the service is better, right? They also wanted us to help speed up the turnaround on their infrastructure requests, like the internal stuff. So they would actually need some environment set up for a new development or test an old development, and they would take a long time to get there, or it would not be as flexible as they needed, or something like that. Again, like I said, they had some problem with outages. They needed to have a more reliable infrastructure, so they wanted to have at least 99.95 uptime, so we try to help with that. And the other thing is, like I said, they had 20 people on staff, so they wanted to make sure that they were actually using 100% of the resources, both human and technological. As you know, this is a government agency, so I don't know if you've heard, but government agencies sometimes are not the most efficient. I don't know, it's just something that you might have heard around. So what did you find when we got there? We found that they were actually provisioning their apps. They have a virtualized environment, right? So they were actually provisioning their apps by having a VM set up with an application running in a dev or in a dev or in a production environment, and they would just clone the VM and change whatever parameters they needed. Just change the IP, change some port setting or something. So the thing about this is that it's really fast, right? You just right-click, clone, and you have it. You just have to modify a couple of parameters. So it's really, really fast. But I'm guessing you can probably think of a couple of downsides to it, right? So it's a machine that's running somewhere, someone's using it. So it's going to have logs, it's going to have temp files. It's going to have a lot of configs that might not really be relevant to what you want, right? You also need to like go into the machine and change the settings by hand, which is not ideal, right? So that's what we found about provisioning. We also found that they had a human DHCP, something like this. So what they had is that they had a big Excel spreadsheet where they have a list of IPs, which ones are taken and which ones aren't, right? Due to some regulations, they couldn't install a DHCP, a real DHCP, on any of their networks. So basically, they just relied on a really big Excel spreadsheet that you had to lock while you were using, so nobody actually reserved the same IP that you were using, that you were trying to register, to use a word. So that's pretty fun. Of course, not everyone uses a spreadsheet, so sometimes you would have to ping the IP just in case, you know. A couple of other things that we found, some of them the hard way, some of them not so hard, but still not nice, is that there was a significant lack of documentation. They basically had an oral tradition. They would just have, oh, you know, you have to call this guy because he knows how to configure this part of the app, but oh yeah, but this was contracted out, so you have to go talk to this guy that actually worked on it for some time, and it got pretty messy. It got pretty messy. We kind of found out all the configuration details that we needed to get things running, but it's an interesting situation. The other thing that we found is that most of the VMs they had were just eyeballed. So they said, yeah, well, we need maybe, what do you think, Frank? Maybe 4 gigs, maybe 8? Yeah, sure, let's go with that. And they would just use that. And there was no real world, no actual load testing. So you wouldn't actually know if you were using that. Some of the apps run on Java, the JVM, right? So you actually specify the amount of memory you want to allocate. So they will have, for example, a server with 20 gigs of memory, and the JVM will have 4 as the maximum heap size. So yeah, that's a bunch of memory that you're not using. And the other thing is that a lot of the apps, well, the thing about the apps is, like I said, there were around 80 apps, different apps. A bunch of those were developed a really long time ago, maybe 6 years ago, and they were static for about 3 or 4, so nobody touched them for a while. And they would just have one server or a couple of servers, and if that one went down, well, you just had to clone it and bring it back up, but it didn't actually, it wasn't actually ready for horizontal scaling. You couldn't just add more servers if you needed more capacity or for redundancy. That was a fun discovery. Some of the cultural challenges that we found, mostly due to how South American Argentinian culture in particular works, and mostly, well, the other thing is any company has a culture, right? So sometimes the culture promotes some things and smothers others. So what we found is, the main thing that we found is there was a big resistance to the Puppet way. There was a big resistance into like the concept of configuration management. Like, we all know that if you're going to puppetize something, you need to invest the time up front, right? So you need to just build it up, make sure that you have all the parameters you need. Maybe you might not have all the parameters for the app, but you need to have at least the ones that you know that are going to need some tweaking, right? But the main thing that we found is that they would just say, okay, but we need it now. Just go do it by hand, and then you can puppetize it. But we know that that's a slippery slope. It doesn't really work like that. If you don't do it at first, the temporary fix is going to be there forever. And it'll just stay that way forever. That said, there was a lot of curiosity from the team, the technical team and the management. They were pretty awesome about trying to learn about it, even though it's not really well known. Slight side tangent here. The whole DevOps movement and the configuration management and Puppet in particular are not very well known down in Argentina. We've been actually trying to push the awareness of the tool so people actually know what it's about and try to find out what it does and how it does what it does, right? So we usually try to spread the word through user groups and webinars and things in Spanish, right? So people can access it more easily. So one of the things that we're working really tightly with these people is to just make sure that they understand what's going on, how are we proceeding, what's the actual step-by-step that we're doing, right? Okay, so let's stop talking about problems. Let's start talking about solutions. So as far as the technical side goes, when the virtualization platform they use is VMware. When we got there, it didn't actually have high availability, so we just basically implemented a whole greenfield stack infrastructure with VMware, Satellite, and Puppet Enterprise. VMware for its virtualization capabilities. Satellite is a funny story because we actually were contracted at the same time as Red Hat for different things, right? So they said, we want Puppet Enterprise for configuration management, but we're also going to have Satellite because we actually have Red Hat and we want the provisioning stuff and the authentication stuff and the channels, the Red Hat channels. So it was a pretty standard implementation. It doesn't really have any technical wonders as far as those things go. There we go. The most interesting thing that we did was we basically made a multi-master Puppet Enterprise setup. I don't know how many of you have tried that. It's an interesting exercise. If you haven't, you probably want to do it, at least for the concept. So why did we use a multi-master setup? Basically because they have, let me just go forward a bit. Yeah, a nice little graph. I told you I like these kind of things. So they basically have some regulations that state that you have to have completely separate network environments. So you can't actually have Puppet environments to separate between the different stages, right? So basically we have the dotted lines are completely isolated networks. They don't have access to the internet. They don't have access to anything. Anything that you want, you're going to have to poke a hole into the firewall. So what we did was we created a master of masters to track the licensing for the Puppet Enterprise, to have actually a single point where you can go and access the console and see all of the reports, see what's failing, and basically have host the Puppet instance. So that way we just poke one hole in the firewall for each of these networks, which is kind of easier than just having every single server try to access the one master or the one VIP where the masters are hosted. So basically what we did is each of the secondary masters are going to have their modules and their HIRA files. So you can actually just grant access. Let's go back a bit. You can grant access to different teams for the dev and the QA and the prod configs. You can have them completely isolated. You can track the licensing. And you can have data completely isolated from the modules and from each of the other environments. Is this making sense so far? Everything good? Just raise your hand if you have any questions. We'll have a couple of minutes of questions at the end anyway, but yeah. So the brunt of the work, the major part of the work was the apps automation. Like I said, they actually didn't have a lot of documentation. So it was mostly just go grab a tarball of the app and start looking at it and going through it and taking out everything that isn't needed and testing it out. Just going ahead and seeing, okay, what if I remove this directory? You have to go talk to this guy and see if this is needed. If not, why not? If it is, why do you need it? Do you need it in dev? Do you need it in prod? Does it have to be the same? How do you deploy it? One of the things that I didn't mention is that they actually were using already Jenkins for, I don't want to say continuous integration, but they did have some integration, and they do use it for deploys, which is pretty cool. It's nice to have. It shows us that even though the DevOps movement and the methodologies are not completely rooted over there, there's some things trickling down, so that's pretty cool. So yeah, the basic workflow that we followed was, okay, let's go with one app. Let's go ahead and grab the thing and start looking at it and start poking it and testing it and see if we can get it to work with the minimum amount of craft, right? Once we have that, let's go to dev. Once we know it's working in dev, cool, QA. And this is an important step. Number 4, load testing and staging. So we actually built a whole new environment dedicated exclusively for testing, for load and stress testing. That way they could actually see if the specs for the servers were right. It's like you can't have a ton of memory if you're just going to use 2 gigs, right? And finally, to production. So the funny thing about production is that we actually, since we did a greenfield implementation, we just set up the whole stack, the whole thing to run in parallel with what they already had. So once we got to production, we would actually run it there. They would actually run some more testing, like functional and load testing on the prod stack. And once they approved that, they had a series of tests they had to do for certification, another regulation from the government. And once they pass these tests, then they can actually just point the external service over to this other stack. It was a pretty nice process. It's 80 apps, so it took a while. It's not really that. It's not really that magical. It's just a lot of brute force, right? It's just going over and over and over again, iterating over the same thing. So a couple of interesting, more interesting points. We actually intended to use the F5 big IP integration. It so happens that when we actually started this, the big IP API moved to version 11. I don't know, has anyone used the F5 big IP module, the Puppet Labs one? Okay, I'm going to assume no. So what happened is that the original F5 module implementation was meant for version 10 of the big IP API. What happened is that when we started this, the API version changed to 11. So of course, the Puppet module broke. So we were left trying to manage a network device for which the API was not responding as was expected. So what did we do? Well, what did I do? I was responsible for that. So I just started hacking at it, and just bugging. I think it was Ashley Penny from Puppet Labs, just bugging the poor guy. I don't know if he's around, but thank you for your patience. So I simultaneously started hacking on the code, see if I can get it to work, and just bugging the guys and see, hey, are you working on this? Are you working on this? I haven't seen any commits. Are you going to get something for the new API version? So I kind of got it to work right about the same time that Puppet Labs actually launched the new version of the module. So that was pretty fun. I lost some more hair about it, but it's no big deal. I'm already going bald, so it's fine. So we got it to work. We actually have the apps registering against the load balancers. We're just basically using it for app registration. We're not using it to actually configure the device itself. They actually have a whole other team, like a network team for that. So mCollective. mCollective comes bundled with Puppet Enterprise, as I'm sure all of you know. So we already had it in the boxes, so why not use it for something? So we showed it to the platform team, show them how they can manage the services, the app services, check their status, see if it's up or down, run Puppet whenever you want, that kind of thing. It's pretty basic. It's not really surprising from a technical standpoint, but it's one of those things that when you don't have it, you really wish you had. Especially when you need to start or restart a service somewhere. But yeah. So what do we do with the human DHCP? We kind of left it like that because since we couldn't actually install a DHCP service, and we couldn't actually change the whole thing, like how they worked and the whole process, what we did is we worked with Red Hat to integrate the build process, the server build process, not the app build process, to actually let them load the IPs before the build and just hand them over to the Kickstart script and configure the IPs that way. So at least you save the manual step of having to log into the machine from the console and change the IPs. So they still have a spreadsheet, but at least they don't have to log into the box. That's a good thing. So how do we deal with the human part and the process part and all of the stuff that they actually needed to do, like the humans have to do, right? Because machines don't operate themselves. So the first thing we did is try to work with the bureaucracy, not against it. I mean, most big companies have some paperwork, right? Some things that you have to do before you can actually do stuff, right? Change management, a ticketing service, an approval board, what have you. Of course, this being a government agency, they have quite a bit of things. One of the things is actual physical paperwork. So you have to fill out a form and hand it to someone. And that was pretty cool. But so we figured out a way to actually have all the paperwork be front-loaded. So you don't have to interrupt the process in the middle just to get something, some server that you want. So you just fill in the form for the firewall rules. You fill in the form for the DNS names. We fill in the forms for the external IP. I don't know. External IP is firewall rules, so you can reach the server from the outside or whatever. The good thing is that now that is all front-loaded. So when you get a request for a server, or well, when the platform team gets a request for a server, they can actually just see, okay, I need this form and this form and this form. Just fill it out at first, hand it in, and let the Kickstart and Puppet runs do their thing while the paperwork gets processed. That's a pretty cool thing. It lets you not interrupt the process, which is kind of nice. The other thing we're doing, this is actually an ongoing thing, is training the platform team to use Puppet so they can operate themselves and start puppetizing any new things that they might find, which is nice. I mean, it's something that they probably want. And the idea is that since Puppet can iterate over the cycle of finding something that you want to manage and puppetizing it and managing it and converging to a state, the idea is that they can actually increase the coverage by themselves. And the third thing that we did is visibility. This is something that I took from most of Gene Kim's stuff. Just make sure that what you do and how you facilitate things is visible, right? Once people see, oh, look, they just set up a new environment in like 5 minutes just to test one thing, and then they broke it down. Wow, so can we do that on our side? So that's another thing. It's like the internal visibility of the tools and the processes and the people, right? Which has been kind of a theme over the past couple of days. So that's a big thing that we're focusing on, and it's been helping a lot. So we're nearing the end of the talk. So what's next? We've puppetized this infrastructure. We taught them how to actually operate it and how to expand it. What's coming next? So from the last couple of months, we've been actually helping them use Docker for a couple of the services. They've been very interested in this. Using actually the cloud, we're working on a hybrid scheme for a couple of their apps. Use the cloud to facilitate the implementation of their applications. Not only from a cost perspective, because handling 4.5 million requests is nothing to sneeze at, right? And thankfully, Amazon can almost always handle it if it's prepared. So that's another thing that we're working on. It's pretty good. It's getting there. And the last part is that we're trying to get more automation on the network, trying to get the switches, the routers, and that kind of thing under Puppet so they can actually start streamlining even more all of their processes. That's pretty much it. If you have any questions, I'm ready to answer them. If not, I can show you the Puppet once more. Whatever you want. Yeah, go ahead. Yeah. Yeah. So the question is, with my Master of Masters, do they have any problems with mCollective? Let me just go back to the slide because it's easier to see visually. So my nodes would be under each of those, right? And mCollective, you would have the actual mCollective service here, an ActiveMQ service there, and another ActiveMQ service up there, right? So far, so good. The thing is, yeah, mCollective architecture is not really that simple. But I found out that it's really not that hard once you get around to thinking about it. The only special configuration we had to make, it's actually supported within the PEM collective modules. You just have to specify an interconnection between each of the ActiveMQ boxes. And that's pretty much it. Once I did that, it worked just magically. It's wonderful. So yeah, we did have to mix a few tweaks. The major one is just, I think it's just a higher thing, actually, because it's a parameter somewhere. So yeah, it's pretty cool. Any other questions? Could you repeat that, sorry?
The change that you were talking about, we did that within collective, not store and forward with ActiveMQ.
Well, yeah, it's actually in the PE ActiveMQ module, not the mcollective one. Okay. Does that answer your question?
Yeah, I think I got it.
Oh, okay, cool. Anyone else? I'll just bring the puppet out one more time. Here's the little guy. Kind of looks like me, doesn't he? Hopefully. Yeah. Okay, guys. So this has been the talk. If you have any more questions, you can just find me. I'll be around here anywhere. And that's it. Thank you for listening. Thank you for your patience.